Let's go ahead and begin. What questions do we have out of 1.5? If you looked at that, which ones would you like for me to go over with you? I'm not going to work them out completely, but I will go through and help you set them up. Okay, which one's out of 1.5? And I can pick some if we need to as well. 3, 9, 10, and what else?
14.
Yep, and 14. So 3, 9, 10, and 14. Okay. Any others to look at? I tried to, if you looked at the notes in the lecture, I tried to cover all the different types. Let's see, any others to look at? Okay. Let's see, I'm going to add 11 because students usually struggle with question 11 as well. Okay, so let's go ahead and get started. We're going to look now at question 3 from your homework out of 1.5. These are applications, and a lot of times with these applications, you're going to solve them, and you may get multiple solutions. A lot of times you'll get one solution that works and one that does not work. But depending upon the application, they also might both work or neither one of them actually fits. But we're going to begin with question number 3. And this is a problem that involves the Pythagorean Theorem. And so this problem is going to involve the Pythagorean Theorem here. So we're going to read the question, and then we'll go through, set it up, and solve it. So let's look at question 3. So a boat is 92 feet from the base of a cliff. If the distance from the top of the cliff to the boat is 23 less than twice the height of the cliff to the water, find the height of the cliff. And they want you to round to the nearest tenth of a foot if necessary. So we need to come up with our diagram here. So what do we have? Well, we've got a cliff here, and we've got a boat that's down below in the water. And what we're going to do is we're going to send a rope just like that out to that boat. So this is what we've got. We've got a boat, and we've got a cliff over here. Now, what do we know? It says a boat is 92 feet from the base of the cliff. So that means this distance from the bottom of the cliff to the boat is 92. So that's your distance across. If the distance from the top of the cliff to the boat is 23 less than twice the height of the cliff. So twice the height of the cliff would be 2x, because our cliff is unknown for the height there, so that'll be x. And then it says it is what? It is less by 23. So that would be now 2x minus 23. Is everyone okay with that so far? You kind of see what I did. So we know it's 92 feet across to the boat. This is the height of the cliff. We don't know. Now we're going to send a rope out to this boat. And it says that rope, when we read it, is twice the height of the cliff. So there's 2x. Less means subtract that 23. Now, what do we know about the Pythagorean Theorem? Well, again, we covered this in our video lecture last time. The Pythagorean Theorem says this. You've got a right triangle, and the Pythagorean Theorem says a squared plus b squared equals c squared. A and b, it doesn't matter which is which, but c has to be the diagonal. So when we look at our equation, what's our equation going to now look like? Well, if I fill in my a, in this case, a is x. So that's x squared. Our b is that 92. We have to square it as well. And c is 2x minus 23. Is everyone kind of okay with what we've done so far here? So we've got our triangle set up. We've got this. Now this c has to also be squared. So we want to use parentheses, and we want to square it like that. How do we handle this equation? Well, it says round, so that probably means we're going to have to apply the quadratic formula. So anytime it says round, it's either going to be the square root property or the quadratic formula, probably. So let's begin by taking out and foiling now that 2x minus 23. That's quantity squared, so we're going to write it out twice, and then we're going to FOIL it. And if we FOIL, we get first times first. So that's 2 times 2, that makes it a 4, and that's x squared. Then we have a 2 times a negative 23, and that's going to make it a minus 46x. We have another minus 46x, and negative makes it positive. And then we have 23 squared, which is then 529. Is everyone okay with that so far? Now we know that these can go together, and that makes it then 4x squared minus, we've got 46 and another 46. So that's going to make that a minus 92x plus 529. Is everyone okay with that so far? Does everyone see what we did? So we set up our triangle, and we drew it. This is where students struggle at setting it up. Another place where students struggle is solving it. So what do we now have? Well, we now have, when we rewrite it, we've got x squared. We've got 92 squared, and 92 squared is 8464. We just squared this out over here and got 4x squared minus 92x plus 529. So this is where we're at so far. Now, if we want to use the quadratic formula, what do we have to set it equal to? 0. Okay? I'm going to move as few parts over as I need to make it easy. So I'm going to move that x squared over because we're setting this to 0. And I'm going to move over that 8464. Then we've got 4 minus 1, that makes it a 3x squared. We've got a minus 92x. And then we've got 8464 that's negative. We're going to add to that 529, so they'll subtract from each other. And that's going to make that a 7935. I'm going to go ahead and finish this one out completely just so we see when we get to answers, one of them is not going to make sense. So first, when we look at these, let's see if we can divide everything by 3. And we can't, because you always want to check first to make sure there's no number in common. So there's no number in common with these at all. Now we are going to apply the quadratic formula. So my A is going to be 3. My B is going to be a negative 92. And my C is a negative 7935. So now we've got that. We've got it set to 0. We've got all of our pieces identified. So now we're going to use our quadratic formula. And for our quadratic formula, that is x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to fill that in. So that's going to give me then negative of a negative 92. Then we've got a plus or minus. We've got the square root of a negative 92 squared minus 4 times 3 times a negative 79/35. And that is all then over 2 times 3. And don't worry so much about the larger numbers. We have a calculator, so we'll be using our calculator. We're going to be rounding again to the nearest tenth of a foot. So let's work with our discriminant first, because that's always what we need to do. And our discriminant is a negative 92 squared minus 4 times 3 times a negative 79/35. When we square that negative 92, it makes it then a positive. So that's 84/64. Double negative makes that positive as well. And we multiply, so we've got 4 times 3 times that 79/35. And that gives us then 95,220. And we can put those together. And that gives us then 103,684. These do take a bit of time to go through. Now we can rewrite. We know we have a double negative here. So that double negative is going to make that positive. So now when we rewrite, we've got 92 plus or minus the square root of this 103,684. And 2 times 3 makes it the 6 there. Now we're going to round to the nearest tenth. So before we do that, we're going to take it out 3 places. Always take out more than what you need. So we're going to take it out 3 places, and then we'll round to 1 place at the end. So we're going to take the square root of this 103,684. So we've got 103,684. We're going to take the square root of that. And that actually comes out to be 322. So now we've got 92 plus or minus 322 over 6. Right, so now we're going to get our 2 solutions. We've got 92 plus 322 over 6. And then the other one is 92 minus 322 over 6 when we split it up. Because remember, there's 2 solutions. Now, let's take a moment to think about what x is. What is x? X is going to be the height of this cliff, right? Now, when we talk about the height of a cliff, can the height of the cliff ever be negative? No. So we can take out the second part. Why can we take out this part here? Well, we can take it out because 92 minus 322, well, that would be a negative number. And we cannot have a negative height of that cliff, can we? So let's go ahead now and finish this out and get our final answer. We're going to round to the nearest tenth of a foot at the end. So we've got 92 plus 322. Well, that is 414 over 6. And that comes out to be an even 69 feet. Let's make sure that is what we want. And that is the height of the cliff. So what is the height of that cliff to the nearest foot, or tenth of a foot in this case? 69 feet tall. That one came out nicely. We didn't have to use decimals. But if it would have, we would have rounded 3 places and then rounded 1 at the very, very end. Now, why can we get rid of the second solution over here? Why can this one go? Because that would make it negative, wouldn't it? And that's what's going to happen on a lot of these. When you work out these questions, what happens is you work it out, you get two solutions or more, and one of them may work, one of them may not. So that was question 3. And I know these are difficult. That's why I cut down the number of questions that I assigned to just 15. Because I know these take a little bit longer than the other sections to actually work through. So let's now move on and look at question number 9. They're all a little bit different, but similar to each other at the same time. Question 9 is a question where students try to make it more complicated than what it really is. Because we're so used to working through some very complicated problems, then we come to question 9. And all we're really going to have to do on question 9 is plug in a value. So let's read it. Let's label out what x and y are. And then we'll see what we need to do with that 13. So your company uses this quadratic model to represent how many units y of a new product will be sold in weeks after its release. How many units can you expect to sell in week 13? So let's first write up our model. So our model is y equals a minus 11x squared plus 350x. Now let's make sure we know what x and y are. X, what is x here? X is the weeks. And y is the units. So we've got x and y here. X represents the weeks, y represents the units. Now, what do we want to find? Well, if we read it, we want to find how many units I should sell in week 13. So we want to find week 13, so that means my x is going to be what now? 13. All we have to do is plug it in. We don't have to use the quadratic formula. We don't have to do anything else. We just plug that value of 13 in. So then I'm going to go ahead and plug that value of 13 in for my x here. And then we'll calculate it out. So let's work this out and see what we have. So we've got 13. We'll square that, multiply it by a negative 11. And that gives me a minus 1859. And then we've got 350 times 13. That is a 4550. We'll add those together. So we'll combine them. And we should expect to sell 2,691 units. So that's what we would expect to sell. A lot of times students struggle with this question because they try to make it more difficult than what it actually is. We're not trying to find the value of x. That would make it more difficult. In this case, they gave you the value of x. We just had to plug it in. So is everyone okay with how we labeled it? Figured out what was what. We plugged our values in, and we were able to just quickly and easily solve it out. Question 10. I'm going to set up question 10, and I'll get you all the way to the very end of question 10. So you'll have to finish it on your own. We're going to set it all the way up except for the very last step. So the difference of squares of two positive consecutive even integers is 28. We want to find the integers. So first off, how many integers do we need? Well, we need 2 of them. So this is question 10. Now these are even. And if you remember, when we talk about even numbers, the gap is 2. So remember, your gap is going to be 2 because these are even. Even and odd consecutive integers have a gap of 2. So my first one is x. My second one is going to be x plus 2 because we have a gap of 2. Now when we set this up, since we're working with a difference, we need to make sure we put them in the correct order. So when we subtract them, we want to make sure the larger one goes first. And our second number is going to be larger than the first one. Because if I'm looking at numbers like 6, what's the next even integer? 8, right? Because you're adding 2. So when we subtract these, we need to make sure that the larger one goes first. And so the second number is obviously going to be the larger one because these are positive. We want the difference of squares. So when we talk about the difference of squares, we're going to always use the larger number first. And we want this difference of squares to be 28. We always want to make sure the larger one goes first with subtraction. Otherwise, you'll end up with a negative answer. So does everyone see why I wouldn't put 1 squared minus 2 squared? Because we want to make sure the larger one goes first. So the second number's larger, so it's going to go first. Now, what do we know about these? Well, we know the second number, that is x plus 2, quantity squared. We know our first number is x squared, and that's going to then equal 28. I'm going to take that x plus 2, and it's squared, so I've got to now FOIL it out. So I'm going to take this, and I'm going to FOIL it out. So when I FOIL this out, we have x times x, and that makes it an x squared. Then we have 2x and another 2x, that makes it 4x. And then last times last, which is 2 times 2, that makes that then a 4. And I'm going to do one more step, and then I'll leave the last one for you to finish out. So we got to here. Now, what's going to happen with the x squareds? They're going to do what? They're going to cancel out, right? So now we're left with 4x plus 4 equals 28. And I think you can finish it from here. I don't want to work it out completely, but you should be able to finish it from here. Now, are you going to have to factor or any of that? No, because this is linear. So how do we solve this? If it's linear, all we need to do is move that 4 over, and then divide by that 4 in front of the x. Okay, so you can finish it. Now you're going to get 2 numbers that are going to work. So you get your first number, add 2 to it to get your second number. So you're going to get 2 numbers back to back. So back to back even numbers here. But you should be able to finish it from here. Does everyone see how to finish that out? So don't try to FOIL it or anything else or factor it. All you do is move that 4 over and divide. Question 11 is working with a formula. So we're going to look at this formula here. We're going to figure out what the pieces are, plug them in, and then how to solve it. So we're looking at how to compound interest. So the amount of money is called the principal, it's called the P, is deposited into an account that earns interest at a rate R compounded annually. Then in 2 years, that investment will grow to an amount A. Using this formula, if your principal is $5,500 and it grows to $6,776.55 in 2 years, what was the investment rate? So we need to make sure we know what is what. So here's our formula, which is A equals P times 1 plus R quantity squared. A is going to be our ending amount. And what would our A now be? So let's read the question. How much money do we end up with? Well, after it's compounded for 2 years, we ended up with $6,776.55. So that is going to be your A. Now, what about the P? P is the principal or the starting amount. So how much money do I start with? Well, it looks like I'm going to start with $5,500. So that's going to be my P there. So is everyone okay with what the values are? And so all we need is the A and the P. We're going to find our R. That's our unknown. And we're going to solve this in a moment by using the square root property. So that's what we're going to be using. So let's go ahead and finish this out. Plug our values in. We've got 6,776.55. That's going to equal that 5,500 times 1 plus R squared. And we want to solve this out for R. We're going to begin by dividing. So go ahead and divide both sides by that 5,500. Because we need to get that R by itself. So let's go ahead and divide through. We've got 6776.55. We're going to divide that by 5,500. And that gives you 1.2321. And that equals 1 plus R quantity squared. Is everyone okay with this so far? So all we did is we just divided. Now let's remember back from 1.4. How do we get rid of a square? Well, we get rid of a square by using the opposite. And what's the opposite of a square? Okay, the opposite of a square is a square what? Square root. So let's go ahead and take a square root. Now, whenever we take the square root, we always have to add in that plus or minus. Remember that. That's very important that you remember the plus or minus. So now we have, when we rewrite, we have 1 plus R equals plus or minus. Now the square root of that 1.2321 comes out to be 1.11. I'm going to write them up, and you're going to have to finish it. So let's go ahead and write up our two parts here. So we have 1 plus R equals 1.11. We have 1 plus R equals a minus 1.11. Now, one of these, just by looking at it, is not going to work. Which one is not going to work? The first one here or the second one, do you think? Second one. Why is the second one, just by looking at it, not going to work? Yep, negative. You can't have a negative interest rate. So that is not going to work. So we can clear this one out. This one's not going to work for us. You can finish it from here. All you have to do is move it over. You'll get your decimal and rewrite that as a percentage. So all you have to do again to finish it out is just move that one over and then rewrite that decimal as a percentage there. Okay, so we were able to get rid of this equation. Why? Because it would have gave us a negative interest, and we can't have a negative interest rate. We're going to look at one more of these, and then we'll take a short break. So that was question 11. We're going to go ahead now and look at question 14. So a rock falls from a tower that is 256 feet high. As it is falling, its height is given by this formula. How many seconds in tenths will it take for the rock to hit the ground? Now, if we hit the ground, what do we know about our height? Well, what's the height of ground here? Our height of the ground should be 0. So let's talk about our equation and then how to set it up. So our equation that we're starting with here is h equals 256 minus 16t squared. Now that minus 16, well, that represents the effects of gravity. Okay, so that's going to be the effects of gravity. Gravity is going to pull this rock down. What do we know? Well, we know we want this to hit the ground. And if we hit the ground, what's our height of the ground going to be? 0. Okay, so all we have to do is just plug in this 0. I'll do a couple more steps, and then I'll leave the last part for you to finish. So we've got this equation. Now we're going to use the square root property. We could factor it, but we're going to use the square root property. So let's go ahead and first move that 256 over. And then I'll rewrite it. So we have a minus 16t squared equals a minus 256. So that's what we've got there. We're now going to go ahead and solve this for the t squared. So we'll divide by our negative 16. Negative and negative makes it now a positive. And that gives you then t squared equals 16. You can finish it by using the square root property. Now, when we solve this out, you're going to get two solutions because of plus or minus. And can we have a negative time? No. So only use the positive answer there, not the negative one. Do we have any more that you'd like me to look at and work through? Are there any others? We have time to look at some more if we need to. Are there any others you'd like me to help you set up? Anything else? Okay, well, then we'll go ahead and take a short break. And then we're going to come back and we're going to look at 1.6. So let's take a short break. And let's meet back here at how about 7:35.